Hello, my name is Mr. Asprey and this is Edexcel IGCSE Sequences. This is Series 2 and we are getting into it with the two formulas that you need to know. The first one is for the nth term and it looks like this, where A is the first term and D is the common difference and N is the position in the sequence. And we also need to know the sum series, so Sn, and this one is given in your formula booklet, n over 2, 2a plus n minus 1d. So those are the ones you've got to know, and let's use them. So this one says the first term is 1, great, we know a, and the common difference is 4, great. It says find the sum of the terms from the 41st to the 100th. Okay, so what I'm going to do is I'm going to find from the first term all the way up to the 100th term. And I'm going to do that by setting n equal to 100. So I'm going to find the summation up to 100, and that's going to be 100 for n over 2. 2 times the first term, which we're told is 1, plus n minus 1 is 100 minus 1, so 99 multiplied by the common difference 4. Okay, great. So I'm going to put that into my calculator. There we go, like so, and I'm going to press equals, and that gives me 19,990. Thank you very much, Mr. Calculator. Okay, and now what I'm going to do is I'm going to find the first term, because we've always got to start with the first term, because we know what the first term is. So the first term up to the 40th term. And the reason why I'm doing that is because I want the 41st term up to the 100th term. So I'm going to take away the first term up to the 40th. And that's going to leave me starting with the 41st term. So how am I going to do this? Well, I'm going to do 40 over 2, because n is 40 in this case. 2 is the first, 2 times 1 is the first term. N minus 1 is 40 minus 1, which is 39, times that by 4, and let's get calculator out again. Okay, here we go, so put that in, and that gives me 3,160. Thank you very much, Mr. Calculator. And what we can do next is we can subtract, and that's going to give me from the 41st term up to the 100th term, which is what we need. And when I subtract that, I get 0, and I get, I'm going to need Mr. Calculator again. In you come. So 19,900 minus 3,160. There we go. Perfect. That's 16740. Lovely. Okay, we've got a question 25 here, and once again, like one we've done before, we're just going to read out what it says and turn it into algebra. So the sum of the first 10 terms. So the sum formula is n over 2, multiplied by 2 times a, plus n minus 1, which in this case is 9, times by d. And then it says the word is, so that's when I write my equal sign. And then it says 4 times the sum of the first 5 terms. So that's 5 over 2, 2 times the first term, and n minus 1 is 5 minus 1, which is 4 times by d. Okay, right, let's do some simplifying. We can divide both sides by 5. So that cancels out this factor here and turns this into a 2 by dividing both sides by 5. We can do 2 divided by 2 is just 1, so that cancels out nicely. So we have 2a plus 9d on the left side, and on the right side we've got 4 divided by 2, which is 2. So 2 lots of this side. Okay, great. Now we can multiply out, so this becomes 4a plus 8d, and we can subtract 2a from both sides to get 2a here, and we can subtract 8d from both sides to get 1d is equal to 2a. Okay, great. So we can't go any further with that, so we're going to need more information, and we're going to use this. I don't know why I cut the 45 in half there. Okay, we're going to use this. So the 8th term. So the 8th term, or A8, we use the nth term formula, which is the first term, A, plus n minus 1, so in this case 8 minus 1 is 7, times by d, and we're told that is equal to 45. Okay, let's use the information that we've got over here and substitute it in over here. So we get a plus 7, and rather than using d, we're going to use 2 times a, so 2a, equals 45. So this becomes a plus 14a equals 45, 15a equals 45, and voila, a must equal 3. And that's what we need, the first term of the series. Job done. Okay, 24. So you can tell these questions are tough. They're right at the end of the paper. Okay, what we're going to do is we're going to read what it says and we're going to put it into an algebraic expression. So it says the sum of the first 2n terms. So that means the position is 2n. And if you remember, our summation formula is position over 2 times a plus position minus 1. And that position is 2n in this case, times by d. Great, and then we're going to read on, and it says that that is, which means equals, and then the next thing we see is 4 times, so I write 4 times, and then it says the sum of the first n terms of the series. Okay, well the first n terms of the series is n over 2, because n is the position, 2a plus n minus 1d. Great. So now what I need to do is I need to simplify this down to get myself an expression for a in terms of d. Okay, I'm going to use my algebra skills here to try and cancel down and do as much simplifying as possible. Okay, first thing to do. 2 divided by 2. That can go away. Both sides of the equation we're multiplying by n, so we can just divide both sides by n. Great, they cancel out. Okay, now let's expand this left bracket here. So we get 2a plus, that times that gives me 2nd, and then minus 1 times d gives me minus d. And what have we got here? We've got 4, and then we're dividing by 2. So it's the same as timesing by 2. So 2 lots of 2a plus, multiply out this little bracket, we get nd, and we get minus d. Okay, so far so good. What I'm going to do is I'm just going to multiply that right hand side by 2. And I'm going to get 4a plus 2nd minus 2d. Now, can we cancel anything from both sides? We can. We've got a 2nd, which can be subtracted from both sides. Okay, this gives me 2a minus d equals 4a minus 2d. And then we can take 2a from both sides. And we can add 2d to both sides. So that will be minus d, add 2d would give me just 1d, and then that minus 2d will go on that side. And finally it says an expression for a, so let's make a the subject by dividing through both sides by 2. And we're done. Okay, another tough question. Big up to the 4 students that I was doing this question with literally today in Maths Clinic. They absolutely smashed this one. Let's do this one. So what's the difference? Well, actually, first off, what's the first term? The first term is k. And what's the difference? Well, you may have spotted it, but it is going down by by a quarter k each time. And we can see this a bit more clearly if we just forget about the k's. So we've got 1k, and we've got 3/4 k, and we've got a half k, and we've got a quarter k. And now maybe it's a bit more obvious, but yes, it's going down by a quarter each time, so it's going down by a quarter k. So the difference is minus k over 4, or minus a quarter k. Okay, great. Now, what does it say? It says given the 15th term. So we've got to use that formula, that one, the nth term one, which we're not actually given, but we have to use this in this case. So the 15th term, we could call it A15, is equal to, well, the first term, A, which is k, plus n minus 1, which is 15, because 15 is the position, minus 1 is 14, times by d. And d, we know, is minus k over 4. And this is equal to, we're told, 90 plus 2k. Okay, looks a bit messy, but we can tidy this up. The first thing I'm going to do is I'm going to times 14 by negative a quarter, and that's going to give me minus 3.5. So this is minus 3.5, and we're timesing by this k here as well. So k minus 3.5k. Okay, what's next? We've got 90, and we've got plus 2k on this side. Okay, let's tidy up the left side. We've got k minus 3.5k, which is minus 2.5k. And then let's minus 2k from both sides, like so, and then divide through by minus 4.5, and that will give me minus 20. Okay, right, you think you'd be done there, but no, we are not, because we have to calculate the sum of the first 30 terms of the series, which means we need the summation formula, which starts by taking the position 30, dividing it by 2 times by the first term, which is k, which is minus 20, which we found down here. So we'll do 2 times minus 20, and then we have to do plus n minus 1, which is 30 minus 1, 29, multiplied by d, which is minus k over 4. So that's minus, and then k is minus 20 over 4. So 2 minuses make a plus, so 20 over 4 is 5. So we times through by 5. Okay, we need to go to the calculator. And here we go, we put it in and we get 1575. Perfect. Here we go, this is a question 23. So again, challenging. And it says the sum of the first n terms is 292. So I'm going to write 292 is equal to the summation formula, which is the position n over 2 times a plus n minus 1 d. Okay, what do we know? We know the second term, the fifth term, and we have those. Okay, so the easiest way to work out the difference if you've got two terms is just to subtract one from the other and then divide by how much space there is between them. So if I do 13 minus 8.5, that takes me from the second term up to the fifth term. So that's 3 jumps along. So if I divide that by 3, that is going to give me my difference. And that is 4.5 over 3. So the difference is 1.5. Okay, and look, we've got the second term here. So the first term, well, it must be 1.5 less than 8.5, which is 7. Okay, so that's just a quick way of working out the difference and the first term if you have 2 terms. Okay, that's going to be useful because it means I can now just substitute this into my my equation. So 2 times a is 2 times 7, which is 14. We're going to get n times d, which is going to be 1.5n, and we're going to get minus 1 times d, which is going to be minus 1.5. Okay, a bit of tidying up. I'm going to take this divide by 2 here and multiply it to the other side, which is going to give me 5. That is 584, and that will be n multiplied by 14. 14 minus 1.5 is 12.5 plus 1.5n. Okay, let's expand out to get 12.5n plus 1.5n squared, and then I'm going to times everything by 2 just to make it a little bit neater for when I use the quadratic formula. Okay, and we set it equal to 0 when we do quadratic formulas, and I'm just going to put them in a nice neat order like this. Okay, great. So we can write n equals minus b, which is 25, plus or minus the square root of 25 squared, b squared, minus 4 multiplied by a, which is 3, multiplied by minus 1168, and that is all over 2a, so that's all over 2 times by 3. Great. And I'm going to go to my calculator, and I might just cheat here just to save a little bit of time and go to equation, polynomial, degree 2, and just type in 3, 25 and minus 1168, and I get n equals 16. Perfect. The other one's negative and not a whole number, so it can't possibly be the position in the sequence. So n equals 16 is my correct answer. Okay, next question, and it looks a bit tricky because it tells us that d is a prime number. Why is that relevant? We'll find out. And it's got all this horrible notation, but essentially the sum to m is 39. So how do we write that? Well, the sum is the position, which in this case is m, over 2, and then 2 times a plus the position minus 1, which is m minus 1, times by d, and we're told that's equal to 39. And then we are also told that if we have a position of 2m, then we get well, this summation formula, and the m becomes 2m like that. The position becomes 2m, should I say, and the value is 320. So what we're going to do now is we're going to simplify as much as possible. So this one, nice and neatly, the 2's can cancel. And with the other one, I'm going to times both sides by 2, which is going to turn that into a 78. Okay, that's much nicer and neater. And let's write it out again, but let's remove the brackets inside the bracket. So I get md minus d equals 78, and over here I get m, and I get 2a, and I get plus 2md minus d equals 320. Okay, now I'm going to multiply out the brackets, so I'm going to get 2am plus m squared d minus md equals 78, and the bottom one I'm going to get 2am plus 2m squared d minus md equals 320. Okay, now these look very similar. So similar that we're going to subtract them in order to get some cancellation, just like we would do a simultaneous equation. Okay, so what do I get when I subtract these? Well, these are going to cancel with each other, and so will these. And maybe for simplicity, I'm going to subtract upwards, so I'll do 2m squared d minus 1m squared d, which is just 1m squared d. and I'll do 320 minus 78, which is 242. Yes, it is. Nice. Okay, where to go from there? Where to go from here? Well, we need to use this bit of information, that D is a prime number. And also, we know that M is a position in the sequence. So M must be a whole number. So in fact, M and D must be a whole number. So let's split this number up into its prime factors, because we know there must be integers. Okay. And this is what we get. So M and D now don't have many options, because M squared must be the 121, it must be the 11 times the 11, and D must be the 2. So M equals 11 and D equals 2. And that is the end of the question. Nice. Okay, next question is pretty nasty. The way that it's described as well is not very helpful. But essentially, the fourth term in the sequence is 6. So I can write 6 is equal to, and remember, it's always the first term plus n minus 1 times by the difference. So if this is the fourth term, n minus 1 will be 3 multiplied by the difference. We've also got U6 here. So what is U6? Well, that will be the sixth term, which will be A plus 6 minus 1, which is 5D. Like that. Okay, so that could be useful. And we've also told here that we're looking for the sum of the 11th term, so up to the 11th term. Okay, so sum to the 11 is equal to n over 2, so n is 11 of course, so 11 over 2, and then 2 times the first term plus n minus 1, which is 10 d. Okay, so we're told that if I square u6, which I'll do like this, and add 18 to it, it should equal S11. So that is what my equation is going to be. It's going to be S11, which is this, is going to equal U6 squared, which is this, plus 18. Okay, right, we need to do some cancelling down here. So the first thing I'm going to do is multiply out this bracket. So 11 over 2 times 2 is 11. And 11 over 2 times 10 is 55. So 55d. I'm going to expand this bracket. It's a double bracket, so I'll just do that up here just to make sure I don't make any mistakes. And I'm going to get a squared. I'm going to get 5ad. I'm going to get another 5ad, and I'm going to get a 25d squared. So that's a squared plus 10ad plus 25d squared plus 18. Okay, so what is next? Let's do as much simplifying as I can. There's not much else I could do really. So what I'm going to need to do is I'm going to need to use this bit of information, aren't I? I'm going to have to use this, and I'm going to have to sub it in to this horrible equation down here, so that I have it only in terms of one term. So let's rearrange this one so that it becomes A equals. It becomes A equals 6 minus 3d. Okay, let's replace all the a's with this, and then my equation is only in terms of d. So this is 11, 6 minus 3d plus 55d is equal to 6 minus 3d squared plus 10 6 minus 3d. This question is insanely difficult. Plus 25d squared plus 18. Okay, right. Let me just scroll down a bit to get some more space. And let's expand. 66 minus 33d plus 55d is equal to, well, I could expand this double bracket. I'll do that up here as well. So that's going to be 36, it's going to be minus 18d, minus another 18d, and then plus 9d squared. So that is 36 minus 36d plus 9d squared. Multiplying this out is going to give me 60d, and it's going to give me minus 30d squared plus 25d squared plus 18. Wowza. Okay. Let's do some collecting. So let's look at the d squareds. We've got 25 plus 9 is 34, minus 30 is 4d squared. Okay, let's look at the constant terms on the right. We have 36 and we have 18, so that makes a total of 54. And we've just done the d squared, so I'm just going to cross them out so I know what I've done. We've got minus 36 and plus 60, so that makes plus 24d. Okay, so those are done, great. And over here we've got 55 and minus 33, so that's 22. And we've also got 66 as well. Okay, let's bring it all over to one side. We've got 4d squared. If we take away 22 from 24, we get plus 2d. And if we take away 66 from 54, we get minus 12. Okay, this can be divided through by 2, like this. And this can be factorized. So in doing so, we will have an AC of 2 times minus 6, which is minus 12, and we have a B value of 1, so our two numbers are 4 and minus 3. So we do 2d plus 4, and we do 2d minus 3, all divided by 2, and this is going to give me, when I divide the left bracket by 2, d plus 2 and 2d minus 3. Right, so d is equal to minus 2, or d is equal to 3 over 2. Okay. Let's have a look at the question. It says that the terms are always positive. Okay, they're always positive. So that means the difference can't be negative, because if it's negative, then eventually it's going to go down and become negative at some point. So that means I can rule out d as equal to the negative 1. Okay, so let's look at what a is now. So let's use, whenever we do like a quadratic simultaneous equation or simultaneous equation, we then look to find out what a is, or what the other variable is. So we can see in this green box a is 6 minus 3d. So a is equal to 6 minus 3 times by d. So a is equal to 6 minus, what's that, 4.5. So a is equal to 1.5. Okay, you think you'd be done by now, but we're not done. We need to work out U20. So U20 is going to be the 20th term, which we will get by doing a plus 20 minus 1, so 19d. And we know that a is 1.5 times by 19, and d is 3 over 2. Sorry, that should be a plus. And what is this going to give us? This is going to give us 3 over 2 plus 57 over 2, which is going to give me 60 over 2, which is going to give me 30. Whoop-de-doo. Wow, what a question. Okay, the finisher. What a tricky question this one is. We got a polygon which has n sides and n is greater than 5, and the angles are arranged in order and they form an arithmetic sequence. Find the value of n. Right. Now, this is going to be tricky because, well, if I were to add up all of the angles in a polygon, I know they would come to n minus 2 times by 180. But I'm going to simplify this problem by looking at their exterior angles, because I know the exterior angles add up to 360 in any polygon. So that's just going to make it a bit easier rather than adding up to this horrible formula. So what are the exterior angles? Well, this one must be 3 because we know the exterior and interior add to 180. Because if we have an interior angle like this, then the exterior angle is on a straight line, so they add to 180. Okay, so we have 3, this one must be 5, this one must be 7, this one must be 9, and this one must be 11. Great. So what's the first term? 3. What's the difference? 2. Yeah, perfect. A is 3, D is 2. So what's the summation formula? Because we know they must add up to 360. So it will be 360 is equal to n over 2, open brackets, 2 times the first term, which is 3, plus n minus 1 times by the difference, which is 2. Okay, let's simplify. I'm going to get rid of this divide by 2 here by multiplying it to the other side, which is going to give me 720 is equal to n. Let's tidy up inside the brackets. 6 and multiplying out is going to give me 2n minus 2. So I get 720 is equal to, well, 6 minus 2 is 4, times by n is 4n, and n times by 2n is 2n squared. Lovely. That's a quadratic which we can solve. And I'm going to divide it by 2 and put it in a better format, the way that I like it, which is like so. So moving the 720 over, making it negative and dividing everything through by 2. Okay, that's great, and I think we can actually factorise this because I know that 18 times by 20 equals 360, which have a gap of 2. So I can say that n plus 20 and n minus 18 is going to factorise this nice and neatly. Let's just double check that. We're going to get 20n and we're going to get minus 18n, so that gives me the plus 2. And again, 20 times 18 is 360, so we are good. So this tells me that n equals minus 20, which is impossible because it has to have a positive number of sides, and it tells me that therefore the n is 18. Yes, we did it. Well done. Try the next one. That was awesome. Bye for now.